You might be able to tell by the statement at the top of the screen how I feel about point slope form. Yep, I think it's awful. I think it sucks. I hate point slope form, but you need to know what it is. So I will show you what it is and then show you how to avoid using it. It's very important that you do know what point slope form is, how it is used, and you know what? If there are some of you that appreciate it and like to use it, feel free to do so. Let me give you a little history of point slope form. You can see this, or on the margin of your textbook, that the point slope form basically comes from the definition of slope, or the slope formula. So let me show you that real quick. The slope formula we showed you said y2 minus y1 over x2 minus x1 equals m, equals the slope. So what they did is they said, well, if I want to try and get the y's by themselves, it's being divided by these x's, so I'm going to go ahead and multiply by x2 minus x1. And if I multiply by x2 minus x1 on the left side, I have to multiply by x2 minus x1 on the right side. Now we know that these will cancel, and we are left with y2 minus y1 equals m times x2 minus x1. So this is basically the point slope formula. Now, the only difference that you will see is in your book, they don't actually write in these little twos. It's like those aren't there. All right? So the way you will see it is y minus y1 equals m times x minus x1. Now, before you get too worried about how we're using this, please remember that it's just a simple case of substitution. We have this form of an equation. So what things do we need in order to be able to fill out this equation properly? Well, let's go back to the title of the equation. We need a point and we need the slope, okay? By a point, they mean we need an xy ordered pair and we need to know the slope. If we know the slope, we can put the slope in there. If we know y and x, we can put y here and we can put x there. So we need to find a point and we need to find a slope, and then we can substitute them into our equation and have an equation written in point slope form. So let's take a look at your first example. All right, your first example, what information are they giving us? All right, let's start with a fresh screen here. They're telling us that we have a point, -2, 3, and they're already telling us the slope is 4. So let's go back to that equation that we talked about. We have y minus y1 equals m times x minus x1. Now the substitution begins. Okay, so the m we're going to substitute here. The y, okay, remember this is an x and y coordinate pair. The y is going to go in, and we're going to put it in place of this second y that you see. And then this 2 is going to go in place of the second x. So when we rewrite that equation, we have y minus 3 equals 4 times x minus -2. Now, the only thing that we can do further in this example is to simplify. Remember that when we subtract a negative, that's the same as addition. So we can write y minus 3 equals 4 times x plus 2. Now, we now have an equation written in point slope form. So let's talk through it again. What did we do? We found the slope right here and substituted that in here. We found, we took the y coordinate from one of our ordered pairs and put it in for the second y. We found the x coordinate and we put that in place of the second x. And we wrote something in point slope form. So let's take a look at another example and try to do this again. All right, here we want point slope form again. Now we have the point 2, 4, or the ordered pair 2, 4. Remember, this is x, and this is y, and we have the slope negative 3/2. So let's try this. Remember my point slope formative equation is y minus y1 equals m times x minus x1. All right, let the substitution begin. My m, or my negative 3/2, will go in for m. My 4, which is the y coordinate, will go in for that second y. My 2, which is the x coordinate, will go in for the second x. So I have y minus 4 equals negative 3/2, because that is our slope, times x minus 2. And there we have something written in point slope form. So once again, if we have a coordinate point, we use an x and the y to substitute into the equation. So right here, we had ourselves a y, so we placed it in here. We had an x here, and we put that in here. We had our slope, and we put that here. Straight substitution. Now, the next thing we have to take a look at is, what if we find something in point slope form, and then it's not quite giving us everything we need? In other words, we don't necessarily know what the y-intercept is in point slope form. So sometimes we have to change it. Now, remember, slope-intercept form is this: y equals mx plus b. So if you'll notice, we've got extra things next to the y, which we don't want. We want to get rid of that. And we don't really have a number by himself, which would be our y-intercept, or b. So let's go ahead and start simplifying this equation. The first thing I got to do is use the distributive property to multiply negative 3/2 by both things inside the parentheses. So I'm going to end up with y minus 4 equals negative 3/2 x, because I did negative 3/2 times x, minus, bring down that minus sign, negative 3/2 times 2, which would equal negative 6/2. Okay? Now we can do some simplifying. First of all, 6/2, or negative 6/2, is the same as negative 3. Okay? And then minusing a negative can be rewritten as addition. So I've got y minus 4 equals negative 3/2 x plus 3. Now, how do I get this y by itself? The inverse operation of subtraction is addition, so that cancels. Whatever I do on one side, I must do on the other. Now I have y equals negative 3/2 x plus 7. So I was able to take my equation, which was initially in point slope form, and rewrite it in slope intercept form. And the reason that's helpful is now I can identify what the y-intercept is. Okay, so I know that I said I don't really like point slope form all that much, but go ahead and try writing some equations in point slope form. Try the got it's at the bottom of the page.